All right, folks, how's it going? Happy Thursday from Mr. Whale. This is the lesson 17 and 18 instructional video, okay? So if it's Thursday, great, you're in the right place. If it's Friday, you should have watched this yesterday, okay? But anyway, so for lesson 17, we're going to focus on that first. The idea is I want y'all to understand the relationship between volume and height of a cylinder, or of a cone even. This works for that as well. All right, now here in lesson summary, right, or in the learning targets, right, our I can statement, we want to be able to explain in our own words while changing the height by a scale factor also changes the volume by the same scale factor. Okay, I'm going to show you what that means. All right, later we'll look at the relationship between radius and volume. All right, but for now, let's check this out. Okay, so if y'all want to follow along up with the graph, it's on page 153, but I'm pretty much going to do this for y'all. If you want to fill it out as well, that's fantastic. But you do also want to take some notes here, okay? I'll let you know what you need to note. Anyway, so here, the idea is if we had a cylinder with 5 units, right? Or sorry, a cylinder with a radius of 5 units, right? And we start multiplying the height by things, how is that going to affect the radius? Okay, so let's kind of figure out an equation for this first. All right, first of all, we know this volume of a cylinder is V equals the radius squared pi radius squared times height. Okay, now we're going to actually write these in terms of pi, just so we don't have a bunch of random decimal numbers. Well, not random, but decimal numbers. Okay, so if our radius is 5, right, that means our equation could be V equals pi times 5 squared times the height. 5 squared is also 25, so we can just put that in there. In fact, let's rewrite this equation so we have V equals 25 pi times the height. Okay, let's use this equation. Let's make some points here. Let's see what we mean. Okay, so let's say we have a cylinder that has a height of 0. Well, the volume is also going to be 0, right? Okay, so let's start off with a height of 1. If the height is 1, right, volume equals 25 pi times 1, well, our volume is just going to be 25 pi. Now let's multiply that height by a scale factor of 2, okay, making the radius 2. 1 times 2 is 2, right? 25 pi times a height of 2 would get us 50 pi, right? Not bad. Okay, let's say we multiplied that radius of 1 by 3. Volume equals 25 pi times 3, we would have a volume of 75 pi. If it was 4, 4 times 25 pi would be 100 pi. And if it was 5, 5 times 25 pi would be 125 pi. Okay, so here we can start to see this relationship, okay? If we multiply our radius by 2, right, then we're also multiplying the volume by 2. Okay, this works for any of these points. If we multiply the volume by 3, we're also multiplying the radius, or the volume by 3. Okay, or sorry, if we multiply a height by 3, then we're also multiplying the volume by 3. All right, isn't that right? Banjo's here doing math with me. He loves it. Don't you? That is very good, good boy. Okay, good job doing math. All right, so this also works here for this one. So let's say our volume our height started out with 2. Okay, if we multiply that by 2, okay, we'd get 4. And you can see here it goes from a volume of 50 pi times 2 to a volume of 100 pi. Okay. So the idea here is if we multiply the height by a scale factor, we're going to multiply the volume by that same scale factor. All right? And let's plot some of these points on this graph. So we've got 0, 0. 1 is 25 pi, 2 is 50 pi, 3 is 75 pi, 4 is 100 pi, and 5 is 125 pi. And y'all can already start to see some key factors in this relationship, okay? First of all, it's proportional. Right, so if we multiply the height by something, we're multiplying the volume by something. But also it's a linear relationship. You can see that because the line is not curving or bending. It's a straight line. Okay? So, pretty Pretty simple stuff here, right? If we multiply the height by a number, we're multiplying the volume by the same number. Okay, now this is kind of a shortcut, right? Because, you know, if you have two cylinders and one is double the height of the other, then the volume is also going to be double the original. Okay, kind of a little shortcut there. So, and I can show you all this as well in this homework problem here too. Okay, if we've got a cylinder, right, and it has a height of h, we don't know the height, but the volume is 48 pi. If you double that height, 2 times h, you're also going to double the volume. So you're going to get 96 pi. Okay, and it works as well if you divide it, right? If we divide the height by 2, we're also going to divide the volume by 2. So that would be 24 pi. Okay, simple stuff. Let's move on to something a little more crazy. Okay, so here, let's look at lesson 18. Lesson 18 wants to show us what happens when we change the radius by a scale factor. What does that do to the scale factor of the volume? Well, here it says, I can explain in my own words why changing the radius by a scale factor changes the volume by the scale factor squared. Okay, so if we multiply the radius by 3, we should be multiplying the volume by 3 squared, or 9. Okay, is the idea here. So let me show you how that works. Let's go to a graph here, all right? So here we've got, there are many cones with a height of 12 units. I put that one in there, just works better. Okay, and we'll let R represent the radius and V represent the volume of these cones. Does that sound good? Okay, so in our equation, we know the volume of a cone is V equals pi R squared times height divided by 3. Okay, now if our height is 12, we can simplify this a bit. 12 divided by 3 is 4. Okay, so we've got this simpler equation set up. And we can rearrange that as well to be V equals 4 pi times the radius squared. All right, now I'm simplifying this just to kind of show you all the relationship between the volume and the radius. All right, so let's move down here. Okay, now again, this kind of works pretty simple. If our radius is 0, well, 0 squared is 0 times 4 pi would also be 0. Now if our radius was 1, 1 squared is 1 times 4 pi would just be 4 pi. All right, now if our radius is 2, 4 pi times 2 squared, well, 2 squared is 4. And then 4 times 4 would be 16 pi. All right, now if our radius was 3, 3 squared is 9. 4 times 9 is 36 pi. Okay, and then let's do one more. Let's say the radius is 4. Okay, 4 squared is 16, and 16 times 4 is 64 pi. Okay, so now here's where we notice this pattern, all right? So if we go from a radius of 1 and multiply that by 2, right? Then the volume has been multiplied by 2 squared, or 4, okay? Not bad. Now again, if we multiply that radius by 3, okay, we get a radius of 3. And our volume has been multiplied by 3 squared, or 9. Okay, so this is what it means by if we multiply the radius by a scale factor, we have to multiply the volume by that scale factor squared. I don't know if this has a homework problem that shows this. Kind of. Okay, so pretty much here we can see in problem 1, there are Milanese cylinders with a height of 18 meters. Let R represent the radius. All right, so complete this table giving 3 possible examples. All right, so we know if the radius is 1, right, it's a cone, no, it's a cylinder, so V equals pi times the radius squared times height. Height is 18. Oh, we're going to be multiplying by 18. This is going to be annoying, but anyway, if our radius is 1, our volume is going to be 18 pi. Now, if we multiply that radius by 2, our volume is going to be 18 pi times 2 squared, or times 4. Okay? What's 8 times 4? Goodness gracious, Banjo. 1224 plus 40. 64. Okay? So, we should have 64 pi in here. Okay? And then if we multiply it by 3, ooh, it's going to be 18 times 9, which, holy cow, I don't really know what that is off the top of my head. But that would be the volume. If we multiply that by 3, our volume is going to be multiplied by 9, okay, or 3 squared. Okay, that's what that means. So one note I would make here, folks, is pretty much, well, obviously we want to know the volume of a cylinder is pi times the radius squared times height. If you don't remember that, definitely write that down and mark it in your workbook. And the volume of a cone is very similar. It's V equals pi r squared times the height divided by 3, because a cone is a third the size of a cylinder. Now, something else you want to note here is just this, that if the height is multiplied by a scale factor, the volume is multiplied by the same scale factor. Okay, very easy to remember. And if you don't remember it, you can always write a quick table and try it out. Try a few volumes, try multiplying the height by 2 and see what happens to the volume. All right, and then between the radius and the volume, if the radius is multiplied by a scale factor, the volume is multiplied by the scale factor squared. Okay, very important there. All right, so those are kind of the key points of this lesson. That is really it for 17 and 18. Okay, so what you should be doing now is getting started on your sub-assignment and then also the practice problems, okay, or the homework problems. So give that a go. Say goodnight to Banjo. He's passing out. Oh, buddy. Such a good boy. Yes, he is. All right, and we'll talk to y'all later, all right? Oop.